We can look at the equivalent cosine identities. If we take a circle, a point on the circumference, and we allow that point to rotate around the circle, we will generate the cosine function. Now we're going to take that point and we're going to reflect it in a line given by 45 degrees. So this point here maps to this point here. Now, if we were to look at the cosine of 90 minus the angle x, well, this is our angle x here, and the 90 minus the angle x is going to be the large angle here. And the cosine of that large angle is going to be the x distance divided by the r distance. Well, the x distance is just this distance here, which is in white. But this distance in white is exactly the same as the distance in white here, which gives us the sine function. So we can say that the cos of 90 minus x is equal to the sine of x. So let's go ahead and we'll look at the next one. Now we're going to reflect our angle x, which is this small angle here, in the line given by 135 degrees. So whenever we reflect it in this line here, this point here will map to this point here. Now let's look at a different angle. This point here is going to map to this point here. So this new angle here is given by 270 minus the angle of x. And you can see that if I adjust this to a smaller angle, we're going to have the original angle x here. The new angle is all the way round to this line here, which is going to be 270 minus the x. Now, whenever we look at 270 minus x, we're going to have this new identity. Cos 270 degrees minus x is equal to minus sine x. And you can see the minus sine x function being generated here. So that's our second identity. Let's look at the next three. So the last three identities are given here. So let's look at this one. We're going to have the value of a positive angle x here, and we're going to have the negative angle x. So we can see that the cos of x is given by this length here in green, which is just this height. And the cos of minus x, well, cos of minus x again is still going to be given by this same length here. So it means that the cos of minus x is just the same as the cos of x. So whenever I press play on this, you'll see this point here being reflected on the horizontal line here, which is the line which is a value of 0 degrees or equivalently 360 degrees. So you can see as we map this round, we're going to have the cos of minus x is equal to the cos of x. Now, the same thing is going to occur for this identity because the value of x is just the same at 0 degrees and also 360 degrees. So we're going to have cos of 360 minus x again is equal to the cos of x. Now we're going to reflect in the vertical axis here. So this point here gets reflected over to this point here. And whenever we run through the simulation, we're going to get the cos of 180 minus x is equal to minus the cos of x. And you can see minus the cos of x here. If we go into the trig identities in Wikipedia, you will see that we've now covered the 5 sine identities and also the 5 cosine identities, which have been generated via reflections. Now we could continue doing this for the tan function, but the tan function will throw up reciprocal functions. For example, the cot x function, the sec x and the cosec x. We haven't covered these reciprocal functions, so we're not going to look at these identities for the moment. But we could continue generating lots of these different trig identities. But for the moment, we'll just stick with the 10 that we have generated graphically. In the next video, we will summarise our identities that we have looked at so far, and we'll add in another couple which are going to be useful for us. But that'll pretty much cover everything we need to know about trig identities. And we'll start looking at using them in examples.